So in this sample, we're going to go over how to use, I guess, a calcite. We're going to use the calcite shell. It's going to have some panels. Inside those panels there'll be a block. Maybe inside the block there'll be a list. in that. Uh, so we'll go over a couple of calcite components in this. One thing is just we'll fire it up, take a look at it, and then we'll get a feel for what it does in that. So saw the loader flash there. Map was ready. Turn that off or hide it. Show the shell and that. So we have our map. We have, we're not sure what we have here, but it's a block, and inside the block is a list. And lists have list items, classic kind of pattern you see on Android development in that. And so when you click on a particular part, hey, we zoom to it, get a little bit of animation happening too as well, and that. So, and we do have a little message here at the top about how many parks are in this list and that. Just so you know, just under max feature count on the service, which is usually 1,000. So, and that. So we don't need to page our queries on this one. And so how do we make this happen, right? And again, we're not doing the whole app here, but this is not a bad base for the app that we're going to build in the end. We're going to have some chips on the bottom in that, which will filter this list. But today it's just how do we make the list happen and the zoom. First, let's jump into the HTML. So look, you can see it all from, here's the body tag and that. So nice and condensed in that. So we have our loader that we saw. We have our shell that appears later. And inside the shell, we've got like a shell panel. Inside that shell panel, we have a panel. Inside that panel, we have a block. And inside that block, we have a list. The list is completely empty. So that means, well, for it to get all those park names, it means from the code side, we got to add them and that. But basically, we just keep adding, and this is sort of the interesting interplay of when do we do something in JavaScript that's more of a JavaScript thing? And when is our JavaScript really doing more of an HTML thing? So we will add a bunch of child elements to this calcite list. That's very HTML speak, if I had to come up with how to describe that. So our calcite list, I mean, it could be just a div, and we're going to put a bunch of divs inside it. Is what's happening, and then it looks like a list with a bunch of list items in that. And so sometimes interacting with these components, they're very webbish, and sometimes, well, I should say HTML-ish. Sometimes it's more JavaScript-ish in that. But in this case, calcite list has a bunch of children. Those children are usually list items. Done in that. Chips, similar, a little bit similar as well in that. And so there are these concepts you have to keep in your head. DOM, HTML, parent, child, and then on the JavaScript side, the loops and that sort of thing. So what do we need? This is a little bit of custom. This is a custom that you can take a look at. Basically, what if your project was getting really big and you're like, okay, I got to organize this into my own modules and that. How can you set that up? So I have a little War.js file and how to, not going to go over this in detail, but basically how do I have my own little logger function and how do I turn debugging on and off real quickly in that for my messages in that. And we'll get into that shortly. So that's a custom thing, and we need two big things from the API or the SDK, Maps SDK, and that is a map view and a map. Stock standard stuff that we do. I have my sort of default settings sections, and this is sort of just setting up, well, I need to hook into interface. How am I going to do that? Looking at these search patterns for the query selector, that's all ID stuff. So we're searching for an ID that says loader splash, shell, park list, and block. Big thing is which layer has the data that I'm interested in. Right now it's layer 2 in that. And this toggle debug on is for me, it can turn my logging off and on real quick. So if I go toggle debug off, then for production, then I'm not putting a bunch of messages to the console. But while I'm trying to figure out my code and why something's broken, then I do a lot of debugging in that. But again, not going to go over that too much in this video. I have some app level variables here. These are things that are going to be shared between functions. So there's this concept of the park layer that we're going to go hunt down in case other people need it. So they don't, once it's done, we just need to do this once. We're going to go to the map in the beginning, find the park layer, boom, everyone can use it after that. We also have the concept of parks local. So there's going to be this concept where I'm going to query the parks, and once I get the result back, I'm going to store it locally on my side and not go back to the service all the time in that. And so if I get the data once in the beginning, that's all I need while the app is running. And people can filter this list as we change. This is not in this particular sample, but as we select different chips, we can filter our parks local lists, and that'll affect the list that we see on the side. But that's future stuff. Here's just stock, go tie into the interface, right? So go find the park list thing because I got to add a bunch of stuff to it. Go find the park block because I'm going to change the title. And up in the top, I'm going to change the title to say how many features are actually in there. I got to get the loader because I got to need to turn it off. Got to get the shell because I got to turn it on. And by turn it on, I mean hidden, not hidden kind of concept. This is you can do later. This is a good place to set up your chips, your action listener on your chips for when the chip selection changes, but that's future. Stock, set up a map, okay? And then we'll set up a map view in that. And so then there's always this dance of when is something ready and what's a good pattern. So I found it for loading, you go to the map first, and the map, we can go to the map, hey map, are you ready? And if the map is ready, then we can say, okay, basically hide the loader, show the shell kind of concept. You can't do this I found, if your view is inside this shell, you can't go view.when. The view's like, well, I'm hidden, so I can't turn, what's the point? And so the code to show the map if the map is in the shell can't actually be in the view.when, okay? Because if it's hidden, then it doesn't run in that. So someone else has to sort of turn that on. And so I'm going to lean on the map to do that. And then I set up the view to use that map in that. And when the view is actually ready, which would mean what? I mean, it means the map is ready. It means the shell is now visible in that. So maybe this is a good time to go get the layer and that sort of thing. There's a little logging statements for me. So I go get the park layer. And so I'm setting this app level variable to that layer in the park so that other people can use it if they need to. And that. And this is the query and that. Now this, I have lots of comments in here so you can figure out what I'm doing and that sort of thing. So I do a query and I'm doing the promise technique. I'm also doing sort of like an object literal to represent the query parameters. So I want the geometry, I want everyone, 1's equal to 1, and I want all the outfields. When that comes back, right, I store it locally. Done. That's what this line does. One line, boom, done. Now I've got it on my side. I don't need to go back to the service anymore. Just let it persist in memory. And we can query it, filter it, do whatever we want with it. It has its geometry. That's what's going to help us actually zoom to the park as well. Now the big thing, not a big thing, this is important to the assignment, not so much this sample. I have a video on data cleaning and prep that explains what we're doing here, but basically there's a string column on our park field that has all the different feature types that are at that park. What we need to do is get that string, okay, and take that string real quickly, turn it into a list, and then take that list and turn it into a set. A set is just a nice way to ask the question. Eventually, we're not here yet in this sample, of the chips that the user selected, does the park have those features? And we just do a set, is this a subset comparison later on in that. And this is to load load the list. So this is the one that does a lot of the work of getting the list ready and that sort of thing. So we'll go down in here. The convert list is, for every feature, go get the string. Now the string could be blank, so skip it if it is. That's right. Make a blank set. So in the end, every park's going to have a set, but the set might be empty because it doesn't have any features and that. But if there is something in that field, I tried a bunch of different stuff, and I wasn't having fun with undefined and null, but this worked. Um, Split the list, right? And that's why I chose to use the a simple separator on the list, because it can work almost in any language in that. And this is pretty close. If you do any Python, it's pretty close to list comprehension in that. But basically, for every item in the list, stuff it into the set, and that little one-liner, and then add an attribute dynamically. So this attribute actually is when we query the feature for all the columns, right? Park structures is not a column on the original data set from the hosted feature service. We're just going to dynamically tack on a thing called park structures to every feature, and it will be the set representation of the features that they have. Now, the concept of a set doesn't exist like in the data types and that sort of thing. So this is, what do you do? We got some base data, and we're kind of like, are we enriching it a little bit? We're giving it data types that aren't possible yet in a hosted feature service, and it's a JavaScript set of all things that we're just going to stuff in there and keep it locally on our side, and that. So that's dealing with I guess atomic. It's a georelational model. It's meant that a particular field is atomic. There's one value in there. We sneak in this string, which is actually a list. I mean, I think I talk in the other video, but JSON structure would be nice, and that. But then the language you're working with has to be able to handle that. We're in JavaScript, so that wouldn't be a problem. But basically, this is something that doesn't really exist, right? In the hosted feature world, hosted feature set world, this concept of a JavaScript set, and that. So a unique list of values, in that. Now again, a lot of this is comments, so you can figure out what's going on, and that. So we can really shrink the code base if we got rid of the comments. This is the one that does a lot of the work. Just so you know, this is what builds the list. So we saw from the interface, there's nothing in the list at first, right? There's nothing in here. So this is the workhorse that actually gets everything into list. And on the final part of this, we'll be calling load park list a lot to reload the list as the user selects different chips in that. Here we update the block header or heading with how many features come back. Remember, we're going to be filtering this, so that is going to be changing as the user selects different things. Again, not in this demo, but we're setting up for that. This is a really simple way to clear the list. See, this is where your mind has to span all these different languages, and even in this one, I'm in Arcade, I'm in JavaScript, I'm in a bunch of different areas, and so my immediate go-to would be, hey, go in JavaScript, go get a reference to the list, go get its items and see if it has a clear function or something like that. But this one is just, hey, let's go to HTML and just nuke whatever's in there, done. And right, so it's a way to do it. So that's one way to clear out a list real quick. So what I'm doing is I'm using the HTML technique to clear the list versus a code technique in that. I think it was, Renee had a quote, JavaScript is Play-Doh, so you have a lot of different ways of attacking this, and that. Again, just logging out, how many features I got, even though it's going to be up in the title, and that. And then for every feature, right, we're going to create a calcite list item in that. And so we're using document create, classic, DOM idea. To create elements, but hey, because we have these web components, we're creating these web components, and we'll make them. A big thing is here, we make it here, and this is how we get it into the list. Now, what we're doing here, it can have a label and a value. If you ever see me work with selects and options, then it's like text and value. And that, value could be anything. So we could take the whole feature, right? Say we needed everything on the feature. We needed all the attributes. We needed the geometry. We could do a JSON stringify and stuff that in there and that. But it just came across to me, that the object ID is a PK. So if I could just stuff the object ID in there, done, right? I do, and so that would keep, I guess, the interface light. That if you were looking through the like in the dev tools of the browser, looking at the HTML, I could stuff stringified JSON object in there, so you'd see a big chunk of text all of a sudden. But here I just, object ID is enough to do it. It is a primary key. So if I have to, and I have the data locally, I can always just use the object ID to hunt down the exact park that I'm looking for and pull the geometry that way. Or I could choose to stringify the whole thing at this moment in time. To keep this light, right, in my mind, hey, if I just put the least amount of information, object ID, it will allow me to get back to the exact feature later on in that. And I also add an event listener to each list item at this point in time in that. So it may sound weird, right? So for every park, there's an event listener. Yeah, every park that we put in here as a calcite list item is going to have its own listener. It's going to be the same listener, zoom to park. And so when everyone clicks on it, that'll trigger our code. And where's our code? Down in zoom to park and that sort of thing. This just makes the block open up if it's collapsed in that. And so again, this is, I guess, the magic of the object ID, and I guess the magic of leveraging stuff that's built into JavaScript. So JavaScript arrays and JavaScript collections usually allow you to run a find, right? And it's going to find the first one, but we're using object ID, which is unique, and that so should be, and that. And so this way, my event handler someone will click on one of the things in the list. It'll trigger this zoom to park. It'll go pull the feature out of my local data set. So I have the 800 and something parks local in memory. And so I'm going to quickly find it. Boom, done, right? And that. And so it'll go through probably doing what we call a full table scan in databases, looking for the object ID in that. And so this is like, well, maybe if I stringified the whole object as value, maybe that's a way to go. But then you would have to parse it, JSON parse it on this side. And so maybe you're not getting any further ahead, right, in that. This is an object structure that's live, that's in memory, that we can just hit real quick in that. And, maybe scaling up, this takes longer in that. I don't know if they do any kind of indexing on this, probably just a full table scan. Now this dot value, right, that's the thing, right? What is this? Well, what is this? Well, because we add the event listener, item add event listener, and the user clicks on the list item in the list, so this is the list item that you clicked on in that. And so we just go this dot value, that'll have the object ID, and so we can just quickly do a scan of the array, find that particular one. It's live and ready to go, and it's a full-fledged feature, so which has geometry, and we can tell the view, hey view, go to this geometry. Done. So it keeps this part clean, right? So there's always this, trade-off thing of how to do something and trying to keep the code clean. Now, this actually is interesting, this comment's still in here. I did run into an issue that I needed to actually add the projection engine and project. And it could have been that I was getting in way too early. This is a thing too. I might have been talking to the map too early, because what probably happens, I've seen this on Android, is the map probably starts out with 3857. By the time the first layer comes in, if it's not 3857, it will change the projection of the map, right? And so these layers are from the city of Surrey, so they are in UTM Zone 10. So there was a time when I was writing this sample and that where I probably got to the map too early, and then I got down this path of, oh geez, I got to project all my polygons. But then on going through this one, I said, I'm going to take this out and see if this is still true and that. And so I can get rid of this comment. Hey, shrink my code base right on and that. And so I mean, in all honesty, hey, go find the park, zoom to its geometry. That's basically what we're doing. Here, a lot of this stuff is just logging to say, hey, I was having some issues, what's going on, and that sort of thing. This filter park list you can use as a future function that you can list. So based on the chips that people select, filter, do a set comparison and filter the list, and then basically recall load park list. Nuke it, use the filtered feature set as the source for the list in that. And so I just want to go over that sample to see some of the techniques that we're using to get this working. Then what you can do is combine the chips and this one, and you'll be pretty close to finishing the mini app that we're building this week. That's all for now.